But throughout this class, we still use Python as our underlying vehicle. So any concept that you learn from some of the subjects, for example, networking, database, operating systems, will be tested and implemented in Python as well. So those who do not have strong, not really strong by taking one semester, but not yet clear idea about your Python skills, do not worry too much about it, but practice is very, very important. So we will practice the Python language in various different areas. Python is not really the strong and robust and formal languages like C or C++, even Java. But it is good language for you to start and quick implement in various different applications. Java has its own strength. For example, over the network, across the network, Java can run remotely, which is good. C is a good language that you can manipulate the system in deeper level. So you can dive deeper and deeper and deeper in C language. The Python is the language that you can implement for any types of applications, even music, arts, fishing.
What's Raspberry Pi use?
Raspberry Pi is like like your PC, which does not have any external devices, but only the small microchips in it. So you can install something that you want to. It's nothing but your PC. Okay, that is Raspberry Pi, and there are so many such things. Raspberry Pi, BeagleBones, DROM, Droid. Droid is one of the most powerful the microcontroller. Okay, this one was overbooked. Now we cannot. I don't think it is a good idea to release. Once we release our privileges, then they need to use this time slot for this space.
Oh, there's another class?
No, not another class. The meeting.
Oh, here.
So only one class, but so many other meetings.
So they use build this class, this room for other meetings, for other.
Oh, we have another the room that is scheduled for the school faculty meeting.
Oh, I saw.
Where I cannot.
Oh, I see.
Because we have some download Linux, particularly Ubuntu, all kinds of Linux operating systems. Then Python is default. Python is there. So Windows is a little different, right? So Python is embedded, and GCC is also embedded. Okay, GNU C compiler. GNU means GNU is not Unix. GNU. GNU stands for GNU is not Unix. Very funny, right? Like PHP. PHP stands for PHP hyperprocessor. PHP stands for PHP hyperprocessor or something like that. But anyway, so those are simply a microprocessor, okay, BeagleBones, Raspberry Pi. So with that, instead of using your laptop, you can coding and program by attaching keyboard, monitor, mouse, depending upon the availability of outlets. Some microcontroller does not have enough outlets. In addition to those, they are just a platform. So delivering to you various different operating systems. Similarly,
doesn't Raspbian have that's its own operating system? Raspbian, like the one that the card.
It has. Oh yeah. Also, there's a varieties. Operating systems already built, or you can update. There's a microkernel systems in it.
Oh, I see.
So small, the memory card can be plugged in and use it.
We're doing it in another class, like one I'm doing it as a project with like a sensor, like a healthcare class, and we're just getting we're getting familiar with like the pinout. You know, like the pinout that you it's a lot of like the sensors and a lot of the different male to female connections and stuff, like things that like I'm not familiar with. So we're all getting used to it. I don't know. I thought maybe you would know something about some things you might have used Raspberry Pi, but we got a screen we're trying to connect, and following certain layouts online, like the pinout.
Yeah, I have a class, but that is for not undergraduate, for graduate courses. We have offered that here at Mercy since I joined. I think about 6 years so far. The course is $555. When you get to graduate level, you may take it. Are you graduate?
Yeah.
Okay. It's going to be offered in the spring semester, $555. The basic requirements is Apple. Okay. If you do not have Apple, then you need to set up a virtual machine and get some Apple OS 10. You may buy.
Maybe Swift.
Yeah, and we install Swift and implement iPhone apps first half, and second half sensor network. All right. So let's get back to here.
Okay.
So this is a networking module that we want to work. What is network? Network is a way to get stuff between two or more things. There's a network, right? So human networking means you can have some way of socializing two or more. There is no network if you are alone. Example is mail, phone systems, conversation, like human conversation, or SMS through devices. Railroad system, there is a networking, right? Two or more cities are connected. Bus systems, highways, roads, any kinds of networks, right? Nervous system, human body. There's a network also, right? Nervous system. So we have organs. How many organs? I do not know. I cannot count all, but organs are connected through nervous system. How many systems? Nervous system and blood, right? nerve and blood. And in Oriental medicine, there is one more, right? You know that, what is it? You know that, right? Chinese says organ. There's another type of networks in the human body.
Chakra?
Nervous system, that we all know. Blood system, that we all know. Another one is some energy.
Yeah.
Some energy.
Spiritual?
Like spiritual, but in Chinese language it is called Ji. I'm not sure how you call it. It's like this. Let me see if I can write it here for those who can understand the Chinese character. Then so like this.
Like in this.
I'm not sure it's.
The
It's you know, it's Taiwan's, we use another kind of, you know, Chinese to write. Just
You know what it means, right?
yeah. I don't know.
That system is also another kinds of networking.
like chakra.
Energy.
Animals.
It's an energy, right?
It means some kind of, maybe some kind of energy,
Power.
Power.
whatever.
What do you mean by whatever? There is no whatever.
Yeah, I even don't know if it's really, you know, it's real or not.
Like power that you can
Yeah, but
create, but it's not physical.
Right. So, for example, human body dies can be explained. There is no key, no such things. Then although our brain still a little bit active and our blood system still runs, but if we do not have that, then
Like a soul.
it's not life. Like soul, yeah. But anyway, that is network. So why they are interesting? Overcome geographic limits, of course, right? And if it is a railroad systems, then we can and airline systems also, right? So we can run one place to another place. Access remote data. There's a real network that we are going to work. Access remote data and separate the clients and server. Why we need to access data remotely? To get some services, right? If we receive some services, then there is a server and clients, right? In our hands-on exercise in Python, in this module, we'll set up client, write some Python program for service module, and also we can create a client. Jess mentioned it this morning before you guys come. Amazon has DOS attack, so we can simulate DDoS. It's not really simulate; it's a real attack. How can you attack the DDoS? You need to have multiple clients, right? You need to create multiple clients, and all clients try to access the same server. Can you emulate that in Python? Thing is this: if, like my system here, this system is still fast, very very strong system. So if I do that, if I create the client to attack, to try to not just to attack, try to access the server manually, even if you are doing very fast server is not going to die. Server can manipulate. So it should be done by program. And that program should emulate the client so fast, like you need to create one client per microsecond. And each client try to access the same server, then within a minute or two, the server will shut down. That type of things. There is servers and client modules. Server and clients are connected, right? And goal is to universal communication. That's for networking. So as you can see here, don't have. Okay, there are three types of network. So local area network, globally oriented network, which is a global oriented wide area network. Since Jess mentioned, we have also PAN, P-A-N. What PAN stands for?
Personal area network?
Yeah, personal area network. So we have a PAN. Okay. And also each of these, we can put W in front. And there is also MAN, right? What is a MAN? Metropolitan area network. So we have also WWAN. So what W stands for?
Wide area.
What did you say? Speak up. You said something.
Wide area.
Why?
Right?
Wireless.
Locally.
Wireless. LAN, we have also wireless LAN, right? So you can access the network wirelessly, right? All of your stations, laptop, now connected. Mine also connected wirelessly. So we are networking wirelessly within this LAN of Mercy community. PAN also wirelessly, right? Personal area network. Microcontroller has also Wi-Fi availabilities. So if microcontroller has Wi-Fi communications, then they can be wireless personal area network. So communication is like that. So one computer say this computer wants to talk to the computer 2 through some communication channels, right? So basically what we need at each side, we need to have some a controller, network controller. So we call it network interface card, right? Network interface card, so-called NIC card at both sides. And this connection, if it is wired, then there is a protocol defined by IEEE IEEE is the Institute of Electrical Electronics Engineering, the international organizations for electrical and electronic engineering. So they defined the 802, just number system. And then 802.3, then that is Ethernet communication. Okay? So through this Ethernet cable, there is a power, energy is moving. We call that amp. Some current is moving. So depending upon that amp, the degree of amp, your NIC card to understand that, hey, there's a data. Then your NIC card to pull the data in and then find out if it is yours, then you take further in it, otherwise drop it, continue to do that. That is the wired communication. At the same time, we have a wireless communication, right? Wireless communication. In this case, we need to also have some antenna, right? We need some antenna. Where is my antenna? Here, the antenna. They need to, in this wireless communication, we have two types of wireless communications. These two transmission or receiver, transmission or receiver needs to understand each other, right? In this case, point to point, or some broadcasting mechanism, so the receiver needs to understand the transmitter. There's no in between. This is the pure wireless communication. At the same time, there is another way that you can communicate. So we have here the antenna. Antenna access to the access point. This is AP access point. For example, your Wi-Fi router. So it's connect to that access points. Similarly, this guy also has the Wi-Fi communication access to this access points. So there are many ways that you can connect. So one computer can connect to other through 802.3, or in this case 802.11. In this case, 802 dot. Can someone say? James? What is the number? 802 dot?
11.
So we have 802.3, 802.11, and then 802 dot. In this case, that is 15. And if you say Bluetooth, then 802.15.1. Okay, for example. So they are all network communication. So you can learn in this module, we focus on 802.3 only. Okay. If you take IASP 560, then we deal with 802.11 and 802.15.1.4 and more. even for GPS, depending upon the time permits. Okay, that's what we are doing. The point here in this slide, so connectivity, right? Connectivity. So one-to-one connectivity. So through that DSL, T1 line, T3 line, and more high capacity communication available. So capacity of communication or data rate. How many bits of data can be transmitted per second? That is called the BPS. So we have 1.5 megabps or 100 megabps or 1,000 megabps. That type of things are discussed. And then there is a propagation delay. As your data is transmitted, there is some delay. So microsecond, millisecond, 100 milliseconds. Particularly in wireless communication, James, we discussed that last night, right? There's some delay. It is not called a delay in wireless communication. For example, CSMA, carrier sensing multi-access paradigm. Multiple senders try to use the same channel of a wireless channel, then there may be some collision. If two or more senders try to send the data at the same time, then data is colliding. The treatment of data collision used for 802.3 may not be the ideal solution in 802.11. So that they developed some others, right? So there is some delay. So before I send, I need to get some delay to see if someone else tries to send. Okay, that type of things. That is a delay planned. Delays, according to the protocol or the software, already planned. At the same time, there are another type of delays. There's more serious problems. Delays occurs because data congestions, right? So many days that are back to back, and we have, for example, network device in between, and then each network device has some buffer size, which means when data comes in, then data needs to be in the buffer and wait for some of the relay, depending upon the network device functions. Some network device try to routing, okay, I want to send this packet to that direction, another to another direction. So routing mechanism or switching mechanism. There are so many different mechanisms can be conducted by a network device. So when it comes to the network device, there may be some delay because of the capabilities. Okay, so that type of delay is possible. And also network wire capacity. Some wires very slow wire. Some wires very fast wire itself, like a fiber optics. That's a very fast network. So it's like a light speed. It's not like real light speed, but like light speed. Why it is not really light speed? Because when our network, when it send out the data, we do not push the data with that great amount of power. We do not use 10,000 voltage of power to push the data out. Usually 100 volt, right? 100 volt cannot be compared with sunlight power. So of course it is not that high, but anyway, that is almost a light speed. Transfer time on the link is number of bits over number of rates plus a propagation delay. So there are a lot of throughputs, a lot of different ways of calculating throughputs. So between 2 points, how fast data can be transmitted. That type of things are calculated in many ways. So in the previous slide, we have a one-to-one communication, right? Let's assume that we have 4 computers. Then we need to communicate. We can wire one-to-one paradigm. So, for example, this computer 1 can communicate to computer 2 through this line, and computer 1 to communicate to computer 3 through this line, and computer 1 is to communicate to computer 4 by using this line. So whenever we want to communicate with establish new lines, that may be possible, right? But very costly. We don't do that, right? In earlier, like 100, not even 100, maybe 50 or 60 years old, our telephony systems, before AT&T invented the multiplexer, then each phone has physical line. Right now it is also, right? Physical line all the way to the control center, and then there is a phone operator. So when you dial by rotating, have you seen that kind of phone? It's a very, very old time, right? No, it's not dialing like this. When you first generate the signal to connect, then yeah, you have to. You've seen that from some movies, right? Which means that rings the bell at the human operator side. So when human operator sees the panels, then there's a lights blitz. Then take the phone, and then that guy says, "Oh, I want to talk to somebody. Okay, I want to talk to Mr. Allen." Then plug his lines to physically to Mr. Allen's phone number, which means that is directly connected. Right? That happened when I was young in my country. We used that. Now all electronically. Now even there is no physical lines installed, right? So wireless is much easier to. But there's no installation cost at all, right? Wireless communication. Only the problem is that if you want to use through the cell, then you need to set up the cell tower. If you want to now smartphone, if you want to connect the internet, and you need to have access points, right? Wi-Fi access points or cell tower. Cell tower relays cell communication. Your Wi-Fi access points relays Wi-Fi communication. And if you have satellite phones, then that is also possible to connect to satellites. Satellite phones are still useful if you go to deep in the mountain. If you go to desert area where there is no access point, where there is no cell tower, then only the points that you can connect to is the satellites. Good care.
Oh yeah, so those like devices that they have that you take.
Yeah, in the ocean, if you've been, then there is no cell tower, there is no access points.
They use geolocation.
Yeah, then satellites,
okay.
Satellites are possible, so you need to connect to satellites.
Because I was interested in getting a device that they sell, like
Yeah, you need to have a different device.
that you take with you to.
Right, that is a satellite phone,
Yeah.
so-called satellite phones.
That's right.
Satellite phones, when I was in company, like 10 years ago, so expensive. At the time, our company sent one guy to Beijing Olympic. It was about 10 years ago, right? Beijing Olympics. So at that time, Beijing does not have strong networks. So guy carries the satellite phones.
Oh, I see.
Otherwise, then communication may be impossible. Locally, if it is communicated through their telephone systems, then they use that, or their Wi-Fi systems, then they may use it. But 10 years ago, it's not really robust. So when we dispatch such guys, they carry satellite phones. The price for satellite phones at that time was $10,000, one satellite phone. Right now, it's less than $1,000. You can find it from, it's like similar to your cell phone. The price of a cell phone is almost $1,000, right? Satellite phones is something.
I know there's something, you heard of Kickstarter, right? Like Kickstarter, where like some people could generate ideas and then like get funded by the public, things like that. There's this one, I'm going to send it to you. It's this device that it makes your phone, if you go out and say several people into an area where there's no service, it makes your phone, I guess, like some sort of like a mesh network, where like you're able to send within 3 miles. Say you can send a message, but within 1.5 miles, say without service, and each user has one with their cell phone. And say like a 1.5 miles, you could use phone, your voice. And I guess it kind of makes it like almost like a walkie-talkie in a way, like something like that. But that's new. I just saw that recently.
Yeah, that is true. About a year and a half ago, Samsung invented the phone. Right now, our cell phone. I want you to think of your cell phone. How many different channels that you can use? I mean, the communication channels. It's not really frequency channel, but the communication. You have cell signals out or receive, right? From there's a cell signals. You have a Wi-Fi signals. What are the signals that you can bring in or sending out? Bluetooth signals, right? Basically, you have 3 types of signals already built, almost all the smartphones. So a year and a half ago, when I taught 555 Manhattan, at that time, we saw there's an announcement, but Samsung doesn't sell it now. They sell 802.15.4, which is Zigbee protocols. So who had, let's say you have Zigbee, that communication. I have Zigbee. Then we can talk each other through Zigbee. Okay? Through Zigbee, which is not cell communication, which is not Wi-Fi communication, which is not Bluetooth communication. It is Zigbee communication. But there's no such phone popularly sold. But as Jesse said, there may be some other Who knows? Somebody. Is it a separate device or is it built-in?
It's a GoTenna. It's a separate device. Yeah,
Separate
based on
device,
mesh
yeah.
number. It uses
Yeah.
smart protocols and radio waves to send messages off grid.
Okay. Yeah. So how do we, the antenna, the different types of antenna that needs to be installed in the device. So your cell phone talk to that device, and device generates the signal to find out somewhere where there is a similar receiver available.
It's through Bluetooth too.
Is it Bluetooth?
Yeah, it's
Bluetooth.
It pairs with your smartphone.
No, Bluetooth is a short distance communication.
But you know, the device pairs with your phone.
Right. It is possible, but Bluetooth and your cell phone. That's
Yeah.
possible. Yeah.
Yep.
Cell phone and that device communicate through the Bluetooth, but that device may not use Bluetooth. May use something else. 802.15.4, which is a longer distance, like a mile or 10 miles. I think maximum 10 miles. Mile is reasonable. So if you go to, for example, deep mountain or deep ocean, then you may need to equip that devices so that
Voice would be, that's true. Voice would be more data, like would you require more data than using messages?
yeah, voice requires more data,
And
right? I mean, bigger size than data that we send. Data is one character, 1 byte. So 1 byte can be in 1 pulse, digital pulse, and you can send it quick. But voice, we need to convert that to digital form, which means, I mean, without loss, if we want to multiplex, then its size becomes bigger. So that is this. But if we have n nodes, then we have n square links required, which is a lot, right? Right, a lot of communication. Not only the line issue. See, if we have so many lines from this node, this computer. Another issue is that how does the guy knows where to go? So another like orientation issue from this computer. That can be, yeah, we know that it can be handled by software. But anyway, there is another issue. Not only the linkage issue, but also the management issues, right? Sending out may be okay. When you receive, say this guy send data to you, this guy send the data to you at the same time, then how can you handle it? So all kinds of issues associated with this. So, hey, then we can modularize. So that we have one physical line, say backbone, and every other device can tap it to connect, right? So my PC is in this, and another PC there, right? In this topology, although this is a long line, but in topological interpolation, which means that like a star communication, right? There is a star, so one dot, everyone link into that. This one dot is nothing but this backbone, right? Think about that. It's a long backbone, all the country has a backbone, and backbones from each country also connected, and all of them can be considered as a dot. So you are connected to that hub dot, although this is geographically wide, it's a long line, but anyway, you hook into that dot where there is so many others also. So once you get in this backbone, you can communicate with anyone that you want, if they are also connected. This is what they are doing, right? This is a network. If you see here, then the printer. This is a very old type, right? Printer is connected to server, but printer itself is connected to the network directly. And there's a client. This is your laptop. This is your cell phone, and here network printer. Okay. Two ways to share. This is very, very old technologies, old taxonomy, like 50 years old taxonomy. We have two types of switchings, circuit switching and packet switchings. So packet switching is currently widely used, and circuit switching has been developed over the phone systems, but it's not really widely used. What happens here, as you can see, the diagram, you're the caller, you want to talk to, for example, somebody in somewhere from East Coast to West Coast. Then you first connect it to the switch, Boston switch, and then through the backbone, and then there's a LA switch, and physically there is a circuit established. Okay, circuit is established. It's established. So as you can see here, number one, establish a circuit from end to end, and then communicate, and then tear down that circuit. It is a very old technique. So through the switch, if you see that, then data to the same switch data comes in at the same time. Three different kinds of data comes in. Then there is a time slot, so time sharing. According to the time sharing, three different messages can flow through the same circuit lines. So, for example, green frame goes first, and blue frame, and red frames. So, frame after frames flows through the circuit lines. That is the way that we do multiplexing and demultiplexing. Multiplexing means each different data can be multiplexed and then sent out. And at the receiver side, now that it should be demultiplexed. Okay. So, this is a time sharing. Frame management over circuit switching network. So, circuit switching network assumes a link capacity is that, and each communication requires R bit. The number of slots is C over R, because capacity is C and R is the unit communication So how many slots that we have? C over R. So maximum number of concurrent communication is C over R. What happens if we have more than C over R communication? So a lot of issues. What happens if the communication sends less or more than R bits per second? So there's a problem with circuit switching. Okay, so problem was acknowledged several decades ago. This is another evidence. After that, they now it's also 50 years old concept. So packet switching was invented. That is used in the internet. So data, if you have one message, then message can be chopped into multiple small size. We call that packet. And packet has header and payload. Each packet has a header and payload. Like here, we have a header and data. And this header also can be divided in multiple different sections. Each section has different indicator. And if you consider 802.3 Ethernet communication, then there is usually 7-layer architecture. Along that 7-layer architecture, the packet is constructed at the sender side, and when the packets, long packets arrives at the receiver side, then receiver unpack the packets, right? So there all of this was possible because software programming become useful. So packing to form packets can be done by software. Likely unpacking the packets can be done by software. So we can emulate that later sessions of this class. So when we receive packets, that we can unpack the packets and identify where this packet come from, where to go, and there are all kinds of useful information found there. So packets are packets generated here in this from your application program, and from there it goes into the different layer of the network architecture, and at the end it leaves your PC, your network card, which is NIC card. At the time your packet moves your NIC card, the packet size, one packet is fully constructed. So you have data here, and then another headers are appended into this. As you move down this architecture, this layer, network layer, different kinds of header is attached into it. So this is full size of packet that moves, that propagates all the way to the sender side, I mean receiver side. When it comes to this receiver side, there is again full size packet. Then there is an application program here. This packet should move up to that application layer, right? Along this layer, as we have multiple layers of network exist at the sender side, we do have that also, multiple layer. So these packets traverse through the same layer but backward, right? In this case, from top to bottom, when it reaches here at the receiver side, these packets traverse from the low level to the higher level where there is finally application layer, right? Apps layer. Here is also app. As this packet traverses over the layers, at each layer, this guy pick up this header file and understand, aha, this goes to another layer, and at the another layer here, this guy pick up the corresponding header and understand what it does, and all the way up to here. So at the end, somewhere, this guy says, when it opens the header, this guy says, oh, this is for PowerPoint slide. All right? The packet switching, if you have PowerPoint slides, that is a long, big file. That big files cannot be in one packet. So files can be chopped into multiple packets. So by sending one message, you may have multiple packets to propagate, multiple packets. At the receiver side, those all multiple packets should be received and combined in the right order. So each packet has some number. Hey, this is a number 1 for this message. This is number 2 for the same message. Number 3 for the same message. So at the receiver side, you can combine them all in the same order. If there is any missing, then this guy will request, hey, I received the packet number 1 through 5 and 6 through 10, but there is there's a missing packet. Hey, can you send it again? In many cases, it resend everything. Okay, so in this packet switching, as opposed to switching, circuit switching, in the circuit switching, once a circuit is established, that all the frames go through that same line of circuits. Packet switching, on the other hand, first packet go through some routes, different route, and packet 2 may go through different route. Okay, not necessarily through the same same path, because circuit is not firmly constructed. There's always a switching. When I receive at the network switching device point of view, when I receive a packet, then I need to determine where that I need to send it, depending upon the availability. So I send at one time, hey, this packet goes there. And when I receive the very next packets, and also even if they are consecutive packets, I do not send back to back. I can send it to different route. Anyway, they all reach the same destination, and all received successfully. Then at the receiver side, all the packets are combined together to produce the original messages.
So the circuit switching, they come arranged. You do not have to rearrange them to be in order.
Yes, automatically, right. So at each network device determines what to do and how to do. There are along the path from sender to receiver, there are a lot of network devices in between. So at each device, there's different decision will be made. So multiplexing is also used similarly. Demultiplexing as well. Multiplexing over the Ethernet is relatively simple, but through the wireless communication, much more difficult, because there's no boundaries at all. Carrier, there's no specific carrier established. Always there's a signal through one signal. Multiple sender try to send different data, then multiplexer collect them all and make one signal and send one signal. That one signal contains all of different senders' messages.
Does that have to do with like data compression?
Technique similar to data compression. But this is multiplexing. We call that multiple accessing mechanism, like CDMA. So this is a network architecture models. When I explained the OSI 7 layers. This is a very typical the architecture, the layers from application to physical layer. So end user, like all of us, when we work, we look at only application layer, right? All of the programs that you are using are at that level, application layer software. We call that application software, right? According to this network architecture, network layer, there's a presentation layer, session layer, transport layer, network layer, data layer, and physical layer. Physical layer is to deal with the physically some power, amps, and resistance, all such electrical engineering concepts established here in the physical layer. Okay. So the network materials equipped for physical layer are coaxial cable or Ethernet cable, telephone lines, or optical fibers, all kinds of physical lines are talking about in this physical layer. Anything above physical, anything below application, they are all something about network software. Here. Data layer, somewhere here, there is a MAC card. Right? What's a MAC? There's so many acronyms for Mac, right? Not Macintosh.
Which message application?
Yeah, it's a media access. What's it? Media access. Yeah. Yeah. Each system has a different MAC ID. Okay. MAC ID can be seen in your MAC address. Let's see. Okay.
It's confusing because they use Mac for so many different things.
if you bring up the window, the command line windows, there you can type IP config and /all, IP config space /all. Then it shows all information about all the network cards. Each network card has some MAC address in it. So, for example, I have a Bluetooth network connection, wireless LAN. Let's say, for example, this. We have an IP address 172.11. 31.56.151. Let's see if there is any MAC address. MAC address is written in hexacode. This is this kind of MAC address, physical address. So F4, B7, E2, 6F01, OB. This is all hexacode in the size of 6. Okay. All right. So DoD proposed the network layer is application, protocol, and LAN layer, and some other layers: application, transport, network, data, and physical layers. Question?
Question, Dr. Yu. What about when you have virtual machine, you have multiple virtual machines running off one machine? Like, only have one wireless, only have one make on this computer, one wireless card.
When you set up virtual machine,
but
you
I
can.
have my main main operating system, Mac OS X, and I have Windows 10 running on my virtual machine, and I have Linux on my virtual machine.
Right.
All
So
using the same wireless card. Do they have?
you're using the same physical wireless card. If you have multiple operating systems running, then when you set up the virtual machine, then you can set up network. So I think there are multiple ways that you can set. If you don't set anything, then you simply use the physical network cards.
It says low-tech hybrid. Looks very different. They have virtualized. You can virtualize the network too.
Yeah,
You can virtualize your MAC address. Very big one.
that is possible too.
It says I have a IP version 6 address.
So there's a configuration issue. So when you when you install operating systems, you can set up either. We'll get back to that when we have a chance. But that is very basic the configuration when you set up operating systems. So which network card that you want to use. Okay, if you have multiple network cards, then you can choose one of those, and then are you going to bridge it, or are you going to use it as network address interpretations, and there are different kinds of configurations available. So you can set one of those. If you don't set, then your guest operating systems uses the default network cards. That is also possible. It's easier that you can do. Okay. So, for example, from merge.edu, if you want to send it to somebody in secure.org, nick, you simply send the message, but internally, your email go all the way down to your layer, and in the physical layer, it moves from one node to another node. This is a network device. If you send a long message, bigger size of message, then one packet goes to that route, and another packet goes to another route, and another packet goes to this way and that way and go that way. So all different kinds of routing or paths possible all the way to the receiver side, right? So, to you, the user point of perspective, simply, hey, I send mail to Nick, but internally, it goes through all the way that complexity models to be performed. That's what we want to understand in this class, okay? Some animations. Okay. So, in reality, when you send something from your source, so this is origin, somewhere here, right? This is your message, M, and it goes down through the layers from application to physical layer. And at the transportation layer, there is another head attached to it. And then at the network layer, an additional header attached. And at the link layer, another header attached. And goes through. The switch and all the way to the router. At the router side, the link router has a little more capabilities of networking. So this guy take out this header and find out, oh, this should go up the network layer, and the network layer, when it comes to network layer, and this guy says, oh, right now we are in Baltimore. We need to send this to Dallas, Texas. Then this guy says, "Oh, we need to attach to that address. I mean, the way it goes to Dallas, so that at the linked layer, this HL is not the same as HL here. HL is replaced at this router, so it travels further." Okay. What about to our home? If you have, the computing power at home, here, this is our home. This is a little old technique, but it's okay, right? You have a telephone line or cable line. Then you have a splitter, so that splitter splitting the telephone signal from data signal. The data signal, we have a modem. Modem will do modulate and demodulate.
Modem?
Right? You don't have modem at home?
Yeah.
You do, yeah. Although it is not physically seen from outside, but it is built in. Modem has at home. It has a modem also. And after this modem, sometimes the router and modem fit together, so you don't see it.
Yeah, mine's different, separate.
So digital subscriber lines are usually used, or cable lines, right? So each line provides different speed. So we can check DSL speed test. Look at there is a website. Let's try if we can do that. I'm going to bring this in here. I'm going to open one more, and then I'm going to type that DSL speed.org. Enter. Wait a minute, what is this? This is not anymore. Let's type the other. DSL report. DSL reports. .com. What does it say? Do you want to leave this site? Okay. So DSL report. What is still using? It doesn't do that anymore, but that's fine. Okay, so this slide explains along that the communication line from your laptop to some destination, and when the data leaves your home, this is your home, but there are other homes also. We have, this is your home, this is another, this is another, this is another. So multiple different messages coming from somewhere. So that along this channel, there's multiple channels available, right? This is some frequency band that can be divided into multiple channels. So channel 1 send the video, channel 2 send the video, and channel send the data, and so on and so forth. So this is a multiplexing. So what happens here is that given frequency band, you have a multiple channels divided. So frequency is divided and each is called a channel. Therefore, multiple messages can be handled together. That is that, right? And there's a frequency division and code division. And many different ways of multiplexing algorithm developed. It's a little more than that. Okay, through this modem and router. So transmission rate these days is 1 gigabit, 10 gigabits, and 100 gigabits. It's very fast right now. Fast means at the same time, bigger size can be transmitted. So at the end, we can say, oh, it's so fast. And also wireless communication is available. So up to this point, we look at the wired communication. From the next slide, a little bit of wireless. So I think this is the right point that we can take a break. Okay, let's take a break, about 15 minutes. Okay, last slide of this module, and we'll do a little bit of more concept of TCP, UDP, and then socket programming. So using socket programming, you may be able to do a lot more. Another thing that we need to do is to emulate, to see the packets that coming in and going out through your network card using the application program. I know some of you already knew, right? Wireshark. Raise your hand if you use the Wireshark. So-called Wireshark, yeah. So we'll look at that. And the information that you can see from the Wireshark can be captured by your Python programs, which means if you do that, then you can extend much more work from there. So we'll do a little bit of that socket programming. So create a socket and socket hooked up to your network cards and capture all the packets. And at each level, we need to unpack the packets and identify what it means in the same way that you could see from Wireshark. Okay. After we do that for networking, we'll look at we'll use, rather than the programming, but we'll use some of the packages already developed for network analysis and network analysis, which is running on Python also. So a little bit of such will be discussed further. So hopefully we can finish up networks in next 3 weeks before Thanksgiving. So after Thanksgiving, we'll do operating systems and database systems, both in Python as well. Okay, this is the last slide of this module, which is wireless access networks. As I said earlier, there are various different specifications already defined by IEEE, 802 dot something. So 802.3 is the Ethernet. You do not use Ethernet much these days, right? If you do Ethernet, then there's an Ethernet cable and then plug into your system. So, for example, your Apple has Ethernet outlet here, Ethernet, and yours may not have Ethernet. No, this is Apple. Sorry. It doesn't support. It doesn't support the older technology. Yours might have Ethernet connection, right? So you have this probably has.
Mine does not.
I agree.
It's new.
Yeah, the new
2015 does not have.
Yeah, the new
New, less features.
If I needed to, you can
Oh, yeah, that is
and
exactly.
USB.
Oh,
That's
USB
great
3.0.
also.
That's
Yeah.
what the
When you need.
It's like the new.
Yeah, doesn't have a CD. Yeah, usually these days, yours doesn't have a CD,
Yeah.
right? CD is useless.
No, no CD.
Right.
Useless.
Yeah. In what case do you need CD?
They try to save as much space as
Tell me
possible.
what materials that you want to carry over CD?
Okay.
None, right? None.
It's too big in CD. You can fit on a USB.
Not even USB is not.
Or
We don't use the USB.
micro SD.
USB the memory.
Micro SD or decide to
Yeah.
save it to the cloud.
Micro SD. Only the problem with the micro SD is it's easy to drop and lose.
But micro
Yes.
SD is speed and too low.
Speed is too low.
Yeah, compared to the USB.
Okay. Oh yeah. There's. I have an SSD. This.
SSD. Yeah.
This is so convenient. So I'm using always this SSD.
So you use SSD as a USB?
Mm-hmm.
Or
Yeah.
I
This one is not portable. Actually, this can be in one a laptop, but I use this as an external device. Reason for that is I'm going to use that plug that in on my Windows and plug that on my Mac, vice versa. Therefore, I don't have to transfer data between Windows and Mac. If you want to use that for both, then the formatting should be the old technology. What is the format type? The file.
FAT32.
Yeah, FAT file table formats. FAT format, not advanced Windows operating system formats.
Apple and Windows have different file systems. Sometimes the files don't work.
Right. Okay. So widely used wireless access network is 802.11. 802.11. 11 has also A through Z protocols available. A and C usually relies on 5.2 gigahertz, all the rest 2.4 gigahertz. And N, 802.11n, they said that it is also covered 5.5 gigahertz. But I'm not really sure. This is so on your left side, this is for Wi-Fi. Okay. Right hand side, this is your cell signals. Cell signals has nothing to do with 802.11 family. Okay, this is a cellular communication. So, for example, GSM. Look at the speed on this slide. This is about 10 megabps. If it's Wi-Fi, 54 megabps. Wi-Fi is much faster than cell signals. But nowadays, cell signals has also extended version, long-term extended version. So it's a lot faster. Right now it is gigabits, right? Gigabps. Same thing, Wi-Fi has gigabps. Gigabps of data speed is reasonable because our bandwidth of the channel is about usually 20 megahertz, one channel. Okay. Which means per second we have 20 megabit data can be transmitted, but we have a lot more techniques used. For example, modulation and multiplexing and encoding. All such techniques successfully applied, therefore it can go up to gigabit data speed, like this. In this Wi-Fi, this is a cell. Right? In this Wi-Fi, we have the family from A to Z, right? A to Z. In this cell, GSM, for example, it has the first generation, 1G, 2G, and 2.5G. So 2.5G is very, very important the version of cell communication. So after 2.5, everything is over digital. And then 3G, 4G, and 5G. 5G is not really fully implemented, but standardized. LTE is one of here. LTE is the implementation of 4G. So LTE is not another version along this. Therefore, we have a colon, right? LTE is one of a 4G implementation. Okay. So when you purchase For example, iPhone. Someone may say, oh, your iPhone is 802.11n or G. What does that mean? Or someone says, oh, your phone is 4G or LTE. When they say LTE, then that is, oh, cell signal is in LTE. When they say 802.11g, it means your data communication. Wi-Fi communication is in that protocol. Okay? So which means there are two different the explanations for different communication. Usually smartphone provides you, as I said earlier, three ways of communication. Wi-Fi communication, which is 802.11, and cell communication, which goes through the cell tower. Your voice and text messages go through the cell communication. Okay? Your text messages doesn't go through the Wi-Fi. Okay. Yeah.
Some
What do you mean by some do? It goes through cell.
there's some apps that only use people over Wi-Fi.
That is different. that is different application. For example, WhatsApp. Then this looks like a text messaging system, but it is not text systems. Yeah, it's not. There's application. There's apps. Of course, if it is apps, then it goes through Wi-Fi.
What about iMessage?
That is, I think, cell signals. So without Wi-Fi, you can also communicate. Which means they charge. When you buy data from your management company, for example, AT&T or Verizon, you buy data, right? That data is the data that you use through cell tower, not Wi-Fi. Okay, so clear, right? So switch over to another module. Socket programming class. Have you heard of socket programming?
Yes.
How? In what way and how you understand the socket programming? James.
There are WebSockets. We're doing with that, but it's how you allocate different sockets and different programs to another level of network tunneling. Allocate part of the network for a specific application, like email server, whatever. Like if you have a residential internet service, they'll block certain ports sockets, so you can't have like FTP file server and a residential internet service. You have to buy like a business line to open all the ports and sockets. So you can have like if you want to set up an FTP file server or something like that. That's how you block and allocate different area parts of your network to use different things.
Okay.
Not really good at explaining it. I think I know.
Yeah, I know you understand. Okay, socket. Forget about network, but in general, socket. What does it mean to you? Socket means
It's like something you
just a plug.
yeah.
So some linkages, right? from outside to inside. On computer, each computer has a lot of adapter that connect to the external devices. So we call that, you have a lot of sockets there, right? So what's the name in another way?
Sorry?
What is another name for that socket?
Ports.
Ports. Thank you. Ports. There's a port. Okay. So computer has, if that is a 32-bit process, then how many ports are available? Usually 65,000 ports available, right? And under there's a port number. So port number 1, 2, 3, 4, 5, 6. So any port number under 1,000 almost standardized and unified. So not recommended to change. For example, your keyboard can communicate to your processor through some port. But if you change the port number to keyboard, then a lot of problem issues, right? If you change it, then change that port to specific application program, then it works for that specific application. But all other programs which assume to use keyboard through the designated port may not work. So that is the issue, right? But when you install a new application program, then you can set the port number. Hey, I want to open my program through this port number 4025, for example, or 6666. So some port number designated. And from outside, if we want to access that specific application, then I need to go through that port. If I access to different port, even if I successfully get in through that port, then I cannot reach the application program that I want, because through a specific port, only the designated application program is available. Okay. For example, web services, web page, website. By default, the port number 80 open, right? 80, or 8088, 8000. That is optional. So 80 is default. That port number is open. Although you said, for example, www.mercy.edu, if you say that, it's supposed to say the port number, but port number is assumed, and somewhere it is automatically attached to when it is route and translate your web address. So you can go through that port number. We can practice that. Let's see. This is our the web browser. Okay. So let's say if you do www.mercy.edu, then it goes to that, right? But by default, if I say 80, 80 is the default port. The socket is specified with the IP address. So IP address, if that is a version 4 IP address, then there's 4 numbers, right? 3 dots, 4 numbers. So at the end of that 4 numbers, or nickname, our case www.mercy.edu. But if I say 80, what happens? What do you expect if I put 80? It goes through the specific that port, but 80, the port number 80 is not secure port. See, it's not going to work. So Mercy web server does not open port number 80 for web services, but it opens for, is it 433 or 443? I think it's 443. That is another port number designated, right? If I say watch this. If I put colon 443, 443 is another port number, another socket. The default port number designated for web services are two numbers, 80 or 443. 80 is general port number. 443 is a secured port number. So our Mercy by default it says HTTPS. Not only because we have S, but because this port number is only available from that web site. If I put then that it works, right? If I put another number, 80, it's not going to work. If I put any other number, for example, 701, what happens? There's nothing, right? That port number is not open for you to come in my web server, right?
You said 443 works?
443 works, yeah. 443 is nothing but HTTPS. So if either you put 443 or no nothing, but simply HTTPS:// that works. Not only that, see our cybersecurity, we have our own web server that is running on here. I recently opened. It is called Secure, CY for cyber, and secure.org. And if you put 80, then it works because I opened the port number 80. On the other hand, if I put
Which one are you
443,
Silo 1?
I didn't open 443.
Silo 1 or Silo
No,
2?
Cy secure. CYSECY.
443 is meaning it's secured, right?
Yeah, correct.
But so if 80 is open, which is unsecured, like why wouldn't the secured one be open?
If you want to access the secure one, then the two systems share some of the certificates between.
But
So
when
once they know, then they can
when you
access.
said it's secured, like what is this secure?
That's a good question. So a lot of things. You cannot, if it is secure, then you cannot send the fake address. Meaning, for example, email. When you create email, you can create fake emails, right? Not through your server, but you can create it. Still create through unsecure port number 400, which is a telnet, there you can attach, for example, sender address. Then you can say www.whitehouse.gov, and you do whatever you want to say and send out. Then it goes through if it is not secure. So more fake communication is allowed. That existed from the beginning. Secure ones exist after we see, oh, there may be some problem. So if it is not the address designated, or if it is not the address that we understand, then we do not accept. Okay. So we protect our port that is secure. Okay. But more than that. If it is secure, then you need to do a secure programming in it. If it is simply 80.80, then colon 80, then you can do whatever you want to do. You can practice all kinds of different capabilities. So for education, 80 is okay. Why should we do 443? That is a systematic protection. So you want to do more learning from that 80. Hold on. So without this, if I don't do anything, then by default it goes through 80. That is this, right? This is what we had last week, right?
So
And
it goes to default, right?
yeah, default is 80. That is when I set this web server, I can designate by saying that 80 is allowed. 443, I didn't open it. Okay. What happens for security point of view? If I open 80, then from outside, somebody wants to come in through that port number 80 to attack. So usually what they do is they scan once they know IP address. By the way, our IP address is not number, right? This is a nickname. It goes through some of the name server, and then I edited the translation. Hey, if you have this number, then come to, if you have that name, www.sitesecure.org, or if you have without www, that is also possible. Without that, simply sitesecure.org. Still, in my translation table, I can convert that to www.sitesecure.org. So automatically converted, right? And then two of those nicknames internally converted to the numeric IP address. It comes to our web server, so that when I click one of these menu, for example, then still I didn't show which file is being activated for this, right? But this is user interactive web page, as you can see here. This is user interactive, so that we can see some of the color changes as you place this slide, right? If we put your name, for example, name, then automatically it says name together with the Dr. John Yoon. And then if you place your mouse, then you can see the team member. If you place your mouse here, then another team member. And if you click that, click is not the same as your mouse movement, right? And then you can see some of theirs, right? But anyway, this is something different. So that is That is our network. So circuit, I'm going to post this. I didn't do that, but I wanted to get some tutorial for circuit networks, circuit programming. I posted some of the sample lecture, and you can learn some IP Internet Protocol specification. This is a detailed specifications. If you visit this website was open and available till 1 year ago, but since a year ago this is not available. But I want to see that if it is not really available, still not available. So let's go there together. Oh, now it is available, which is good. What I want to share with you, if you see here RFC source book, and then IP protocol switch, if you click this, then you can see ALP. ALP is when you say www.sitesecure.org, then that is a name, nickname. It should be translated, right? So that is address resolution protocol is activated. But anyway, there are a lot of those available. If you click IP, then now you can see all the IP header information. See here, IP header. This IP header, what is the size of an IP header? So one line here, that is 4 bytes. So how many lines? 1, 2, 3, 4, 5 lines, right? So 5 times 4, 5 times 4? Yeah, 20 bytes long. So each packet, the IP header itself is 20 bytes. And then you have your payload. Say you want to send 1 kilobyte of messages. So in addition to 1 kilobyte, you have 20 bytes for IP header. If it is a TCP or UDP port, then more. For example, port number, according to the port number, so big numbers, right? And they are all attached in addition to that IP header. So this is a port number. For example, if that is 80, then 80, there's a TCP, and protocol is HTTP protocol. That is designated. Port number 80. 443 in another way. 443. 443, there's a TCP, but that is HTTPS. Of course, it accepts HTTP. If 443 is available, then SSL, TLS, this is a secure socket layer or transport layer security. Both are available. And in our server, Linux server, it opens also port 22 for secure shell. secure shell so that you can log in from outside. This is a secure shell. Before we have this secure shell, then there is a telnet protocol, which is telnet. Is it 400? I don't remember. Telnet is Oracle secure backup. Let's see. We can search. Where is my search? Oh, there. Okay, I have telnet 992, that's too high. 107. Yeah, maybe 107. Or 89. 23. Yeah, this is the lowest number. 20. Oh, just right before, right after this. So SSH or telnet. Telnet is insecure remote access. SSH is secure remote access, which means secure means server and client needs to share each other the credentials or certificates. So they need to get to trust each other. After that, they can communicate. If it is not secure, for example, telnet, they don't care. Like port number 80, and my port number 80 does not care who wants to access our web server, which is okay, right? The web server, there's a no, nothing, user can enter their data. Only 2 pages open, one easy and the other one JavaScript, so it's nothing. Okay, so
many ports.
oh yeah. So you can learn some ports and you can create the ports. So when we practice to set up server and clients in Python, then we can set up the port number. Yeah, next time. Interlayer relationships. Each layer uses a layer below. Remember that that we have 7-layer architecture, right? In network, OSI architecture is a 7-layer. 7-layer. Upper layer, it is called the application layer, and bottom we have physical layer, and one above we have a link, and then data, session, transportate, whatever, presentation. So those are the layers. So I have here my application running, and I have a click button so that I want to send some data to the server. Then that data comes through this down all the way to the physical layer. At each level, not only the data that wants to submit, but there is a header will be attached. So this header is something about interlayer relationships. Okay, so this guy explains where I am, where it go, things like that. So data from the upper layer can also be header on the data from the layer above. So it can attach it further and further, right? an IP address, IP characteristics. IP is the datagram based. Okay. IP is not really reliable, which means it doesn't care. Once they send out, if successfully arrives, it arrives, but it may drop some points. So although we have an IP, we need to set up some additional the capabilities that can carry the packets to be transmitted successfully. There's extra capability needs to be added. Another thing that I want to point out here is IP has nothing to do with the physical address. For example, if we have 172 dot something here in New York, but this number may be available in California, may be available in UK, doesn't really matter. Right? IP address has nothing to do with the geographic. IP address also has nothing to do with the MAC address. MAC address is unique to your hardware, but IP address is not unique. IP address has nothing to do with your hardware. So to pinpoint who is the attacker to my system, then IP address is not a good solution. It may be a good reference for you to track down further, but it doesn't give you solid solutions at all. UDP. UDP and TCP, those are two major protocols that we usually use. So UDP is also datagram based, but it's a connection list, which means as opposed to TCP. So usually when you say UDP, you can compare with the TCP also. So UDP send usually bigger data because it is unreliable. And if there is an error, but protocol doesn't care, but application can handle. On the other hand, TCP, there is a connection. It's not physical connection, but anyway, there is a connection. 2 points are connected. So we say that it's connection based. Application doesn't need to error checking, but TCP protocol itself handles the error, which is good, right? So there is a difference between TCP and UDP. Usually, UDP is a stream based, but here in this case TCP came up here. But streaming data, almost all the streaming data go through this UDP. When you download the video, or when you watch the video over the internet, then it comes through UDP protocol, not TCP protocol, which means the sender of your video does not care whether it successfully reaches at your side or not. But TCP, it takes care of the transmission. For example, email, then it checks whether it arrives at the recipient successfully. If it doesn't arrive, then your sender program try to send multiple more times. Okay? Usually a couple of more days, depending upon the configuration. Still, it doesn't reach the destination for some reason. One of the typical reasons is that the server at the recipient went down. Then that server does not receive, so that your email does not reach. So sender server identifies that, detects that issue. So hold it at some buffer and resend it multiple times. And when it reaches the expiration date, then it sends it back to you by saying that, hey, your message bounced. That at least sender understands that your message does not didn't go through all the way. That's a TCP. UDP don't care. For example, YouTube, that is the server, right? You click YouTube video. For some reason, some frames doesn't come successfully, so that when you watch, some scenes are tilted and skipped much. Still, the YouTube server does not receive any notification by saying that, hey, your frame number 1023 to 1054 doesn't reach it at the request by Mr. XYZ, so can you resend it? No, you don't need it, right? That happens to video, audio, and all those things. And circuit, as we looked previously, it's like this. This is a circuit, electric circuit.
Did you post this?
No, not yet. Right. All right. This is after this. Then we will do some of the programming. Okay. In 2 weeks. Okay. So last thing that we need to do next about 20 more minutes. What we will do. I want you to open. I want you to open the web browser. No, not this. Okay, somewhere here. Open Wireshark, www.wireshark.org, and download application program. If you click download and then choose one of these, whichever applicable to you. My case, Windows installer 64 bits. And if you have a Mac OS, then do this. If you want to see source code, then do that. So once you download it, then it comes into your
Where we download it?
Wireshark. Where? It doesn't matter, but usually it comes into your download folder. So I'm going to show to you where
Where is
I...
it blocked? Sorry, no. Did you download it?
Oh, is that right? Why? I don't know why. Blocked from where? From our Mercy Mavericks Wi-Fi?
Yeah.
But anyway, if it is saved and installed properly, then you will have this kind of icon. This icon. See here, that icon? So I want you to click that, double click. And I'm going to wait. Here, new version of Wireshark available. My case, because I downloaded earlier, new ones available, so I will do that on install updates. The way that you do it. Mine is okay. Why not yours? So block in your case. We have your own. Huh?
Got it. Yep.
I have Linux. So you want Linux to
Doesn't matter. Linux possible. macOS possible. All platforms available. So mine is ready to update. So I click that. Then I have this message. Do you want to allow this app to make change to your PC? Why not? Click yes. And then it says Wireshark or one of the associated program is running. Please close it first. Which one's currently running? Because I ran my Wireshark, so I'm going to close this Wireshark.
It's letting me download it.
Close that and retry. And then it says Wireshark 2.2.0 is already installed. Would you like to uninstall it first? I don't need to. Oh, it is already installed. Then why? But let's try to anyway uninstall it and install. Yes. Maybe there may be some minor different. Click yes, and I agree, whatever it is, and click continue to yes and next. Wireshark Legos desktop icon. I don't need file extension associated trace file extensions to Wireshark. Can accept that, and it should be on. In my case, program files, C drive of program files. There is a subfolder called the Wireshark that is acceptable, and then Win PCAP. So Windows Packet Capture Program. Packet Capture Program is needed for the Wireshark, but I don't need to do because I have already. So forget about this, not install additionally. I don't need to install any other. Okay. problem? Mine complete? Finish? Okay. Yeah, so wait. Okay, so I'm going to click the Wireshark program. So it is like this. Welcome. Oh, this is quite different from previous. So right now, if you see here, I want you to take a look at, these are the interface card available in your system. Not all of you have the same interface card. Each one is different, right? Not all of you needs to have these many. Maybe more than mine or less than mine. But if you see here, then if you see some signals, then that card is currently actively running. So if you click that, then that card is activated. So all the packets through that card is now appearing here. It's not really nice interface. I think maybe some of the view is not good.
If I run Wireshark on a virtual machine, will it be different? Say it over. If I run Wireshark on a virtual machine, will it be different?
Oh, because you have your virtual machine is running. So if you click it, it hook up that interface part.
Because I have it, I can do it on Linux or I can do it on Mac. This is not virtual machine. Linux is.
This is your physical interface card. So click it and do this.
If I do this on the virtual machine, will it be different results or the same?
Depending upon the configuration, if your virtual machine, if you bridge it to that the physical interface card, then that's the same. It keep receiving, right? So if you click one of those, I want you to click, for example, currently I do not run any particular program, right? But I want you to open up a web browser. Let's say I want to do www.newyorktimes.com. Fastly error, unknown domain. New York Times is not known. nytime.com. Wow, it's not known. CNN.com. Okay. CNN.com. Then somewhere here at the end, then we see some of the TCP. I'm going to click one of those. Okay. You can click any one that you want. Then, if that is a TCP, let's try to TCP or TCP is better. Yeah, TCP. With this TCP protocol, see here there's a protocol. Let me explain more. There's a timestamp and source address, destination address. If you see the top pane, there's a multiple columns available, and there's a protocol column, and there's a length of there's a data size and the information. So look at the protocol. We can filter that but today, just manually, choose one of the TCP, then that packet, this is a packet. Packet is called frame here. The entire packet, packet number 50520, there's headers, 4 headers attached to that packet. So frame number, and then Ethernet, IP, and TCP. Okay? So each one, if you unfold this, then you can see detailed information, interface ID, and encapsulation, time shift, all kinds of those. Just collapse that and then expand further for the Ethernet, and then IP, Internet Protocol. So let's look at this Internet Protocol. All available. For example, there is a bit set 0100, the first 4 bits. 0100 means number 4, so that is a version of this IP address. And then next 4 bits, which is 0101, which is number 5, right? That is the header length. Header length is 20. Number 5 means 20. And then you can unfold further so that next 6 bits indicates differentiated service code point. And then last 2 bits of next 1 byte is explicit congestion notification. And then next length tells us the size of length. Next byte, this is 1 byte, another byte. And then we have a flags for 3 bits tells us what it is, right? So many of these tells us and great information. For example, the source 172.31.56.151. This is the source IP address, and destination IP address is this. So source IP address is doesn't look good, but then that is, watch this. If I move, then we don't see that code. I click this, and look at the highlighted. Highlighted code is AC1F3. Okay, so AC1F3, that should be, that's a code that should be interpreted in your Python code, and if it computed properly, then it gives you 172.31. Whatever that number is, right? Here, this is a hexacode. This is a real code transmitted, but this code needs to be translated into this. How do you know which one's what? That is something that we looked at. Where this RFC source book, IP protocol suites. Then you have IP. And source IP address. Source IP address written in 32 bits. So that 32 bits is nothing but here. Somehow here 32 bits from here to there, right?
Why is it cut off like that?
I don't know why. Maybe. I need to be downloaded the proper solid the visualization program. But my visualization here so messy, right? But what about yours? Anybody? You run Windows, right?
Yeah.
Yours better than this, right?
What do you mean better than this? I just
My see here, the bottom. Yeah, yours. It should be like this.
yeah.
I did not like that.
Somehow, yeah. I need to read on. Anyway, this is a quick tutorial of your Wireshark, but we are not going to work on this already built Wireshark program as is, but we'll look at another way that the how Python script can do similar things that you can obtain from Wireshark. Someone may ask, hey, why we do the similar things if it is not more than Wireshark provisioning? Then I would say Wireshark, that's keep flipping, right? It's very hard to capture, but if you do Python programming, then you can do it on your own purpose. You can select dynamically on your own and continually. You can run your program for 24/7, and then in your program you can save it and send it to you by emails automatically. So all of those things possible. Okay. So I'll see you in 2 weeks. Next week no class, but week after that.